Hello and welcome to Embedded Internals. This is 7th episode of our series, Pointer Thinking series. In this episode, we are going to learn about function pointers and callback architecture. Let's uncover biggest hidden truth, and that is pointer points to data. Actually, it's not completely true. Pointer points to address, and anything which has an address like variables, executable codes, arrays, structures, even function, pointer can points to it. So we can say that pointer points to address, and everything in memory has an address. So pointer can points to anything which has an address, even the functions. We should know that all the functions like our main, printf, or any user defined function we used in our code, everything resides at a particular address. Like variables lives in stack segment, data segment, bss segment based on where it has been defined. It defined at local variable, it will go in stack segment. If initialized global variable or static variable goes in data segment, and if uninitialized global or static variable, it will go in bss segment. Where the functions go, they resides in code section. All the functions resides in text segment, having the same permission, read and execute, don't have any write permission to it. So whenever we write any function like void hello, we declare this function. Compiler places this function at particular address like address 1000. There hello function will reside. Like the variable are have the address, functions also have the address. It is similar like when we defined int x is equal to 10 and compiler places x at any particular address like 200, the value resides 10. Similarly, when we defined any function, compiler placed that function at some particular address. So it is like 1000 pointing to function hello. And we can print the address of that function as well. One thing we need to understand, which is the difference between a variable and a function, is that the function label like hello, it act as an address of function. So we cannot modify the function label. This is exactly same when we defined any array. So array name act as an address of first element. So we cannot change the label. Likewise, we cannot change the pointer. We cannot change the label of function as well, because they both points to the addresses, not the value. Okay, whereas in case of normal variable, we can change they don't resides in the compiler area, only the address and value, whereas these labels are itself an address, so we cannot do any modification on these labels. So whenever we have to call any function, we can simply call like hello. So it resides at particular address. Compiler will say jump and the address, like hello resides at 1000, so jump 1000. I have printed the address corresponding to our main function. So simply we know that every function has an address, and the identifier like main is treated as the address of that function, so we cannot change it. So main directly print the get the value of this. Let us see what address we are getting. Some address. Let me show you from where we are getting this address. Most probably this will be from code section, that is executable, having read and executable permission. So this is the memory of our code area, and the address correspond to it is 58A7 FEE9. So FEE9, this 9000 some value 169. So most this address range is coming from this area, having the permission read executable but not write permission. P stands for private. So from this area we are getting the getting our address. Function pointer means instead of calling address directly, store address in a variable and then call it. Okay. Why this is an indirect approach? Let me first define, let us see an example. Void. So FP is pointer to function. Pointer to function. By this definition, we mean that FP is a pointer to function having no arguments, and returning void, nothing, or returning void. Let me give you another example. Let us return something. Integer add, let us take two variables, integer. By this definition, it means that add is a pointer to function having two integer arguments and returning integer. Okay, so when we have to read this, it is like list is a function to pointer having one structure argument and two integer argument returning structure. So this is the way how we read the function pointers. Now when we have to call this function, like fp is a function to pointer, let us assign some address to this function pointer fp. So we have a function hello. Okay, when we have to assign, we have assigned this function pointer address hello. Okay, when we have to call this, we will simply call this. So by this term, it means calling of a function pointer, assigning. And so this is the declaration. So fp is a function pointer taking no argument and returning nothing. So we have declared a function, we have defined a function hello and assigned this function hello to our function pointer, and then we are calling. When we do this calling, it will call the function hello, and whatever is in this function we will get. So it is simply like hello has some address in the memory. Hello is a function and it has some address like 5000. So when we are calling it from fp, it is simply like fp is 5000. So compiler will say jump at the address this. Let me show you one example of same. This is the same example. We have declared the function pointer. So fp is a function pointer taking no argument and returning void. In the main function, we have assigned function pointer a function name or address, that is hello. This is just to print the address of main function, and there we are calling the function. Okay, fp. And hello function we have defined just a print statement. Okay, so let me show you the output. It's like this is the address of main, and this is the output we are getting. Let me print the address of hello function as well. So both function has some address, and when we are doing calling, it is simply called to this particular address. So it will reach to this address and print the statement or whatever is inside that function. Next is why function pointer exists. Why not call directly? Because function pointer allows choosing at runtime. When we call the function directly, it is like choosing the function at compile time. But with the help of function pointer, we can choose at the runtime which function need to be called. And this is use. Runtime based on any operation, basically in the hardware system, when any event can occur at that time, based on the event occurrence, we can decide which function to call. So this benefit we get from the function pointer, and this is the reason function pointer exists. Let me show you one example where we have choosing runtime which function pointer to run. Okay, this is a code where we have three function pointers. We have a function pointer which takes two argument of integer data type and returning integer. Okay, so this fp can be anything which we will decide at the runtime which function address will go into this. So we have three functions: addition, add, subtract, and multiply. Simply we are adding, subtracting, and multiplying. Okay. So we need to choose at runtime. Therefore, I have just given the option and enter the value. And based on the choice what user has made, we will perform the operation. So if the addition case 1, it will go to addition. And there is the function calling. So a and b we are sending as argument and returning, we are storing return value into C, just printing those values. Similarly for subtraction and multiplication, default invalid operation. So this is the code. Let me show you the output. So it is saying choose any operation to choose the value. Hey, I am calling from subtraction function. So this the benefit that I can call any function at the runtime is the reason why function pointer exists. So runtime selection is the main reason of the existence of function pointer callback architecture. Similar to function pointer, this also gives a benefit of choosing a function, choosing an operation based on any event at the runtime. And this is most widely used in real world programming. So imagine we have in hardware where an event has occurred, a button has been pressed. Okay, so we have in GPIO where GPIO 1, there one button has been attached, and when this button will be pressed, we let the code. So it will simply show the event that button pressed. So what to do when this event has occurred? We will register a callback function. When the button will be pressed, callback function will be invoked and perform the operation. And in the kernel or device drivers or embedded firmwares, we have seen callback function are most widely used. So when I give you the visual flow of this, it is like a particular application. It is calling some on button, on button, and based on that on button, a driver has the address, because everything has an address, so function also has an address. So driver stores address, so that will go into button event. So it is like, okay, this event has occurred at this particular address, and at when this event will occur, we already have registered callback function. So driver will call callback function named as on button, where we have performed any operation, like when the button is on, uh, do something or anything we need to perform, we have that logic inside our callback function. So this is all what happens when any external application give any event, and based on that event, our driver has stored address. Driver let us know that okay, this at this address particular event has happened, and based on that event we will have the registered callback function. We just call that function and and perform the operation whatever is required. So like in the embedded, we have GPIO, register IRQs. Every IRQ, read, write function, everything happens using callback function. So void, this is handler. When the function will happen, call this handler, which is a function pointer. So this handler will simply be called, and handler has been registered. Application, this is just driver. GPIO driver has an registered callback function, and at the application level we have simply let toggle. If it is on, perform the off operation, anything. Okay, and this GPIO registered IRQ have the callback function, so we will simply call GPIO register IRQ, and at this event we will send led toggle. This is our callback function. So when this event occur, just invoke this handler, and this handler at the application level will do this operation. So event occur, driver will simply call the handler, and at this handler it will come to know, okay, it has to call the function let toggle. So it will go and call the function. Driver will execute handler. So when this handler has been executed, we will reach there and we come to know, okay, at this function, this driver function has been registered. So this function will be called. An application runs the code. This is how the hardware event occur and callback function has been called. And callback functions are most widely used inside our driver code. For the interrupt vector table or ROS scheduler internals, everywhere we have seen the callback functions. Let me show you one example of callback function. So this is a callback function example where we have from the main, we have a registered callback that is execute, and the execute we have sent a function as an argument. So function is hello. When we check the function, there it is receiving the function pointer. Okay. And CB is a function pointer where any function hello will go. So it is calling the function from here. From directly calling the main, we have one extra function from where we are calling. So it is callback function. This is function pointer, this is callback function. So hello will be called CB, CB corresponding to hello. So hello will be called and it is like hello from callback. No direct call. No, we are not calling directly the hello, we are calling directly from callback function. Okay. So this is GCC callback.c, hello from callback. Okay. Similarly, let me show you one more example of where callback function has arguments as well. So in the main function, we have just three of the functions: calculate, which is similar to the function pointer example we have given, calculate some value, and the operation. Okay, it will go to calculate, where this function is as function pointer. So operation is a function pointer to a function taking two arguments and returning void. So operation and taking argument x or y. An operation can be what? This time we are calling add, so add, subtract, multiply. So first time it is add, it will simply go to the add function and perform the operation. Okay. So simply get the sum, subtract and multiplication output. Okay, we understand what is callback function and what is how the callback architecture work. This is basically for the any hardware events. When the particular hardware events, we already have registered callback function and we just call that function and perform the operation. So this is how callback function work. And we have seen the real life example of GPIO driver code, and I have shown you an example and how it is written inside the driver code inside the kernel. Now comes common beginner mistakes. First is syntax problem user do, like void pointer fp this. This is wrong syntax. It means a function returning pointer. This is fp is a function which is returning pointer, void pointer. No. When we have to declare the function pointer, right syntax is fp inside bracket then call. Okay, so this is the right syntax. Complete main name meaning will be changed. It is simply the function returning pointer, function returning void pointer, and this will be fp is a pointer to function taking argument null and returning void. Okay. Uninitialized function pointer. Uninitialized function pointer leads to a crash or any undefined behavior, so we should avoid it. So we have declared a function pointer and simply call it without initializing which function to call. This will lead to crash. So right way is, after the declaration, we should also initialize this function pointer by some function like hello. name of a function, then call. This is valid operation, whereas it does not have any address where to jump. It will lead to crash. Third common mistake is wrong signature or argument. Like we have so this function pointer taking integer as argument and returning integer. And when we are going to assign, like we have declared a function hello. So when we assign fp hello, the signature is different, because now the hello function will signature should be like one argument and return type, but here the signature is just returning void. So wrong signature, or we can say type mismatch. This will lead to error. So the way we have declared the function should be written in the similar way and called. Okay. So when we say data pointer, it is simply address pointing to data, right? But when we say function pointer, it is address pointing to behavior or function. And function pointer benefit is that we can decide at the runtime which function to run. So this is the key takeaway. So in this episode, we have seen that function has address and function pointer stores function address, and calling through pointer perform indirect execution, and callbacks inject behavior dynamically. Interrupt vectors are function pointer tables. RTOS scheduler also use function pointers. Linux drivers use function pointers. Function pointers and callback function are most widely used inside the kernel. So when I give a simple flow chart, it will simply like we have particular function name like hello, and this name will act as address, and by this name we will call the function pointer, which is an indirect call, and that will execute the function or execute behavior. So it is like data pointer is pointing to data, whereas function pointer pointing to code. This is foundation of all the callback architectures, events, interrupt handling, RTOS, device drivers, object oriented behavior in C, and embedded HAL designs. That's all in this episode. In the next episode, we are going to see void pointers and generic programming. Stay tuned for same. Thank you.